Welcome back. This is going to be a video about section 7-2 for college algebra. Now listen, if you've got questions on specific problems or concepts in 7-1, if you don't mind, maybe email me, shoot me a video or something like that, and maybe I'll answer them via email. Maybe I'll make a video to answer some questions. But this is going to be 7-2. Now, remember the broad topic for chapter 7 is solving systems of equations. And in 7-1, we solved some systems of equations. But they were all just what we call 2x2 systems, where you have two equations and two unknowns. Well, today we're going to, as you see here, I have a system of equations where there are 1, 2, 3 equations with 1, 2, 3 unknowns in them. Okay, so it's easy to get going around in circles when you do this. So I think if you just kind of follow this procedure, because remember our goal here, to find the solution to this system, we have to know a value of x, y, and z, such that if I substitute that ordered triple into the first equation, I get a true statement. I substitute the same x, y, and z value into the second equation, I get a true statement. And of course, if I substitute the same x, y, z values into the third equation, I'd also get a true statement. That ordered triple, okay, which is like an ordered pair when there's 3 numbers. That ordered triple that makes a true statement in all 3 of these equations, that's called the solution to the system of equations. Okay, now what I'm going to do, I'm going to start just by numbering these equations just so I can refer to them. So we'll call it that equation number 1, that's equation number 2, and that's equation number 3. All right, here's what you have to do. You're going to start with 2 of the equations. Okay, it doesn't really matter which 2. Okay, but what I'm going to do is I'm going to take 2 of these equations, any 2, and then I'm going to use them to eliminate one of the 3 variables. Okay, I'm going to choose to use equations 1 and 2. Okay, now I don't have a lot of board space here, and I don't want to do a whole lot of erasing just because I don't know, we may end up losing something. So I want you to look at just the equation number 1 and equation number 2. And I want you to think with me about if I use these 2 equations to eliminate one of the variables, which one would be the easiest to eliminate? Okay, remember we learned a method yesterday, I think, called elimination. Well, it looks like if I take those 2 equations, equation 1 and equation 2, that if I simply add them the way they are, that y variable will be eliminated because negative 4y plus positive 4y would go to 0. So what I'm going to do is I'm going to write right here, I'm going to write 1 plus 2. Okay, that way I don't have to rewrite both of those equations. So I'm going to add them like this. Okay, so 3x plus 2x makes 5x. Negative 4y plus 4y makes 0. I'm not even going to write the 0. Okay, just when I add, the y terms are eliminated. 2z plus 1z makes 3z. And then, of course, on the other side of the equation, negative 13 plus negative 9 makes negative 22. Okay, so notice now I have an equation that does not have a y in it anymore. That's great, okay. Now, what we have to do next is choose another set of 2 equations. I can choose, let's see, I used 1 and 2 the first time, so I could use either 1 and 3, or I could use 2 and 3. It doesn't really matter which ones I choose, but what I'm going to have to do with the pair of equations that I choose here is I'm going to have to use them to eliminate the same variable that I eliminated when I used the first 2 equations. So I'm either going to have to use 1 and 3 to eliminate y, or I'm going to have to use 2 and 3 to eliminate y. Doesn't really matter which one. I'm going to choose to use 1 and 3. Okay, so I'm going to do equation 1 plus equation 3. Now, I know what you're thinking. Okay, you're thinking, wait, if you add equation 1 and equation 3, that's not going to eliminate the y variable, and you'd be absolutely right. Okay, so what I'm going to have to do is, if you remember from yesterday, what I'll have to do is I'll have to multiply maybe one or both of those equations by something to make these coefficients on the y variable, because that's the one we want to be eliminated. I want to make them equal and opposite. So I'm looking at that, and it looks like if I multiply the equation 1 by 3 and equation 3 by 4, that'd give me a negative 12y and a positive 12y. And that's what we want. Okay, so maybe what I'll do is, instead of just writing 1 plus 3, I'm going to write 3 times equation 1 and 4 times equation 3. Okay. Now, so I'm going to take 3 times equation 1. So that's going to give me 9x minus 12y plus 6z equals negative 39. So that's 3 times equation 1. Now remember, I said I'm going to take 4 times equation 3. So here's equation 3. So that's going to be 8x plus 12y plus 20z equals, and that'll be negative 20 over there. Can you see that okay, Eliza?
Mm-hmm.
Okay. All right, now if I add these, remember I'm taking 3 times equation 1 plus 4 times equation 3, it looks like I'm going to get rid of the y variable. So 9x plus 8x is 17x. Negative 12y plus 12y makes it 0y. 6z plus 20z is plus 26z. And then on the other side, let's see, negative 39 plus negative 20 makes negative 59. Okay. Well, now I want you to look at what we have here. I have this equation, which only has an x and a z. I also have this equation, which only has an x and a z. So essentially I have a system now with 2 equations and the same 2 unknowns. Well, we learned how to do that yesterday. Okay, so what I'm going to do is I am going to erase maybe some of this stuff. Okay, I'll leave the 2 equations that we're going to work with. I'll erase this intermediate stuff. You can erase this line. Okay. And now I'm going to look at these 2 equations and think, well, which one of those 2 equations is going to, which one of those 2 variables is going to be easiest to eliminate? And man, none of them look great, do they? Okay, I don't think anyway. Let's just eliminate the x variable. How about that? So I've got to make these coefficients equal and opposite. Okay. Well, all right. I think the least common multiple between 5 and 17 is going to be like 85. So I'm going to multiply this equation by negative 17, and I'll multiply this bottom equation by 5. How about that? All right, so I'm taking this equation times 17. Or is that what I said I was going to do?
Negative 17.
Negative 17, okay. So that's going to be negative 85x. Negative 17 times 3z is negative 51z Oh, and here comes the fun part, right? Negative 17 times negative 22. Well, I have no idea what that is. Eliza, do you have a calculator with you?
I have one on my phone.
Okay, my assistant Eliza is going to do that for me, so I don't have to do it long. Just do 17 times 22.
I know. 374.
Okay, so 374. Wonderful, wonderful. Okay, now I'm going to have to take this equation times 5. So I'm going to get 5 times 17x is 85x. 5 times 26z, let's see, that's 130z. And then 5 times negative 59 is going to be, I think, negative 295. Okay. So I'm going to erase this now, this part. And we will add these. Negative 85x plus 85x, that goes to 0. The x variable is eliminated. Negative 51 plus 130z, I think that's 79z. And then 374 plus negative 295, I think makes 79. So the x variable was eliminated, and if you look at this is going to allow us to figure out z is, as you can probably tell, going to have to be equal to 1. If you divide both sides by 79, you get z equals 1. And the first piece of the puzzle has fallen into place. Okay, we know that in this system, the solution, in the solution to this system, the value of z has to be 1. Okay, now what I can do is I can kind of work backwards to start getting the other variables. Once I have one variable, most of my work is done. Now, one thing I noticed that I can do, I can take that value of z and I can substitute it in for z here, or even up here, and it looks like these are easier numbers to work with. So what I'm going to do is I'm going to substitute this value for z into that z without multiplying that equation by negative 17. So I'm going to write 5x plus 3 times 1, which is just 3, 3 times 1, equals negative 22. And I can solve that for x. So I'll subtract 3 from each side and get 5x equals negative 25. When I divide by 5, I would get x is negative 5. So look, now I know 2 pieces of the puzzle. Okay, I know the x value for the solution to the system has to be negative 5, but the c value has to be 1. Well, now what I can do is I can take those 2 values and I can substitute those 2 in for z and x in any of these 3 original equations. So let me erase a bit of this. And maybe I'll just do that use that top equation right there. So the x is going to become negative 5, so 3 times negative 5, okay, minus 4y, and then plus 2 times z, which is 2 times 1, equals negative 13. And then if you notice, I just have one unknown left. I can solve this pretty easily. So 3 times negative 5 is negative 15 minus 4y plus 2 equals negative 13. Yeah, I'm kind of taking forever, but that's the way things go sometimes. Okay, so negative 15 and 2 plus 2 makes negative 13. So I have negative 4y minus 13 equals negative 13. If I add 13 to both sides, look at that, I get negative 4y equals 0. And then if I divide both sides by negative 4, I get y equals 0. So,
why are you saying 0 instead of 0?
Oh, my mistake. 0 will work just fine. Eliza, that means 0 in Spanish. You didn't know that?
Well, we're not This isn't supposed to be
No, I
in
know, I know.
Spanish.
I like to speak in multiple languages. Maybe I could do
You
French
aren't
or
fluent
German.
in any language except English, though, and you're not very fluent in English.
That's debatable, right? Okay. So to write this as an ordered pair solution, or sorry, not an ordered pair, it's an ordered triple, right? So negative cinco, cero, y uno. Okay. That is the ordered triple. That's the solution, and that's how you would, type it in on WebAssign. Of course, I think they already give you the parentheses for you. Now, let me tell you something about the assignment here. Okay, most of the problems are going to be like this. You got to solve a system of three equations, three unknowns. There are going to be some that ask you to do it using Gaussian elimination. Now, Gaussian elimination to me is not worthwhile when we're doing a 3x3 system. So we're going to save Gaussian elimination, which is really nothing other than just using a matrix to solve this for when we have a bigger system. Because believe it or not, kids, we're going to do systems that are even larger than 3x3 here in a few days. Okay, yeah. Stay safe. Email me with any questions, and have a great weekend. Don't go anywhere except with your family, and don't interact with people who are not your family. Goodbye.